Welcome back to College Algebra, and we're doing our series on the basics. Today, we're talking about addition with fractions. In just a little bit, we'll get to our basic principle when adding fractions. The basic principle is that we always have to use a common denominator when we use fractions. But I don't want to start with our basic principle. Instead, I'd like to start with an actual concrete example, because I'm hoping that we can make that basic principle make sense to the point that we don't have to memorize it. It's something that we understand and can agree that it should definitely be true. So let's start with the example. 2/3 plus 1/4. How do we add these things together? Well, if you're not sure what to do, what I would do is I would represent these visually. And the way I represent 2/3 is with a circle that has 3 pieces. And the way I represent 1/4 is in a circle that has 4 pieces. And then I might mark these pieces somehow. So I might mark the 2/3 pieces like this. And then I might mark the 1/4 piece like this. And so you'll see what I've done is I've now created 2 pieces that represent 2/3 of the whole, and 1 piece that represents 1/4 of the whole. It's important to go back and remember what the numerator and denominator represent. Numerator is what counts. It tells us how many pieces we have, and you hear the word num, which is like from the word number. Denominator, denom or nom, is the naming, and it tells us the type. It tells us what type of pieces we have. So this means we have 2 pieces, and the piece types are 1/3 pieces. It says we have 1 piece, and that piece type is a 1/4 piece. Before we go further, let me answer the problem the wrong way. Let's answer the problem the wrong way, and I know you'll be excited about this. The wrong way is to do 2/3 plus 1/4 is to simply add across the top and get 3, and then add across the bottom and get 7. Now, this might seem like the right thing to do, but the answer is it's wrong, so I'm going to put a big not sign on here so that you don't ever do it. Furthermore, you'll lose points, it'll make me sad, and in general bad things happen. So don't add like this. But the question is, why don't we add across the top and add across the bottom? Well, you'll notice that we definitely have 3 pieces. We have 1, 2, 3 pieces. But these pieces are not of the same type. They're different types of pieces. It's almost like saying if you have 2 apples and 1 orange, how many do you have? And the answer is, who knows, because they're different types of objects. And so you can't just add different objects together. You only can add things that are of the same type. So this is going to be a basic principle. It's going to lead us through most of addition this semester. And this, we can only add things that are of the same type, whereas these are different types. Now, how can I make them of the same type? Well, I can make them of the same type by using a common denominator. And what is a common denominator? A common denominator is further subdividing these 2 pieces until these pieces have the same number of shapes. The way I would do that is maybe divide these into 3 pieces. Maybe divide these into 3 pieces, and then maybe divide these into 4 pieces. If I did it correct, I should have 12 pieces on both sides. Let's see if that's correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you'll notice both pieces now have 12 pieces, so now they are of the same type. And the question is, what's our answer when I put these together? When I put these together, the answer is, let me mark these together. I think this is a 12. That has 12 to it. And so now when I put them together, I can say how many of these types do I have in the first image? I have 1, 2, 3, 4, 5, 6, 7, 8. So I'll mark off 8 of these. 1, 2, 3, 4, 5, 6, 7, 8. And so I got all of those for my red images. Now how many do I have for my blue, or for my green? I have 1, 2, 3 of the green images. 1, 2, 3. And so now you can see how many total pieces I have altogether. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so my answer is that I have 11 pieces. And then what type are the pieces? The pieces are of the type 1/12, because there are 12 pieces altogether. Now, we could have done this using common denominators. Using a common denominator, the problem would look something like this. 2/3 plus 1/4. I might multiply both the top and the bottom, I might multiply this side by 4, and I might multiply this side by 3, so that I get the denominator to have the same number. Notice multiplying 3 by 4 and 4 by 3 ends up with the same answer. So 3 by 4 would give me 12, and 2 times 4 is 8, so I have to have 8 twelfths. 4 times 3 equals 12, 1 times 3 equals 3, and so I would have 3 twelfths. And now I put them together, and I get 8 plus 3, which is 11 twelfths. Now, this is a little misleading, not misleading, but there's a temptation to try to maybe add the twelfths or do something with the denominator. But remember, our denominator isn't counting, our denominator is telling us what type of pieces we have. So if we have 8 of those pieces plus 3 of those pieces, then we get 11 of those pieces. Like if we have 8 bananas and 3 bananas, we get 11 bananas, not 11 banananas or something, whatever happens if you put the denominators together. So don't add the 12s, don't combine them, leave them just separate. And you'll notice that these common denominators that we just wrote perfectly match the pictures that we drew right here. Here's our 8 twelfths, here's our 3 twelfths, and here's our 11 twelfths. So this is our basic principle that goes throughout the adding, and that is only add things that are the same type. The same goes for subtraction, and that is we only want to subtract things when they're the same type. And so let's now bring out our big rule. And that is, whenever you're adding and subtracting, we always use a common denominator. But why do we use the common denominator? We use it because the common denominator makes both fractions be the same type of fraction. And unless they're the same type of fraction, we can't add them together. Let's try this problem. 4/15 over 3/20. We need to think, what can we multiply both of these denominators by to get the same number? Well, one option is to kind of go crazy and multiply this number by 20 and this number by 15, and that in fact always works. So you can always multiply 20 times 15 to get this denominator and 20 times 15 to get this denominator. Let's go ahead and do that, although this problem, you could do something a little bit simpler. You could multiply this one by 4 and this one by 3 and have that work out just as well. But let's go ahead and do it. So I'll go ahead and go 20 and 15, 20 and 15. And if you remember back to what we talked about when we did our simplifying section, if you multiply both the top and the bottom of the fraction by the same number, it doesn't change the value. You get an equivalent fraction. Now, we need to ask, what is 4 times 20? The answer is 4 times 20 is 80. What is 15 times 20? 15 times 20 is 300. You could calculate those out on your own. I have confidence in you to do that. Now let's come over to this side. What is 3 times 15? 3 times 15 is 45. What is 20 times 15? 20 times 15 is 300. So we found our common denominator. We can't add here because these two are of different types. 15 and 20 are not the same type of fraction, but now 300s and 300s are the same type of fraction, and so we can add them together. So we can subtract 45 of our pieces from 80 of our pieces, and that gives us 80 minus 45 is 35 pieces altogether, and these 35 pieces are 300s. This, in my mind, is a perfectly reasonable answer. However, it's always nice to kind of reduce and simplify. If I was going to simplify, I might divide both of these by 5 to simplify them. 35 divided by 5 is 7. 300 divided by 5, I have to think about it just a second, is 60. And so I get 7 over 60 for my answer here. So that's our big rule. Our big rule is always use a common denominator. If you ever find yourself trying to add fractions without a common denominator, you're making a mistake. And furthermore, we find our common denominator through multiplication, because multiplication is the way we create equivalent fractions. We don't create equivalent fractions using addition or any other operation. It's always multiplication. Okay, as we often do, I'm going to give you 2 problems, and I'd like you to try these 2 problems. Pause your device, give them both an attempt, and see if you can get the correct answer on each one. Okay, and we're back. I hope that you gave them a good attempt, but I'm going to work them with you, and we'll see if we can get the correct answer. On this one, I'm going to multiply this side by 9 and this side by 5 to get my common denominator. My common denominator is 9 times 5, which is 45. 9 times 3 is 27. Over here, 9 times 5 is 45. They should be the same. If they're not, you've made a mistake. And 1 times 5 is 5. Now I add these together. 27 plus 5, it looks like we get 32 and 45 for our result. So 32 divided by 45 is our answer. And we found it by getting a common denominator and then adding the numerators together but keeping the denominator the same. Okay, now let's look at part B. And we could find the common denominator by multiplying 12 by 18 and 18 by 12, and that would work. I actually see a little bit of a shortcut. The shortcut is to multiply 18 by 2 and to multiply 12 by 3. This isn't anything that probably would have been obvious to you, but it'll be nice, and you can see how we don't always have to multiply by the number across. The reason is because 12 times 3 gives us 36, and 18 times 2 gives us 36 as well. So as long as the numbers multiplied give us the same pieces, they become the same type, then it works out just fine. 13 times 3 is 39, and 25 times 2 is 50. So now we're adding 39 plus 50, and 39 plus 50 is 89, and these are type 36, so we have 89 out of 36, and this ends up being a pretty reasonable answer for that problem. Good luck working the problems on the homework, and I'll see you next time as we talk about multiplication and division of fractions.